So hello and welcome to problem 413. So here we're also in the life insurance setup where we are asked to consider an insurance contract on a couple consisting of two spouses with initial ages X and Y. So let's just draw up one person and another person. And let's say that this person is Y years old and this person is X years old. So we assume that the insurance company uses a unisex mortality table, i.e. the same age-dependent mortality rate mu is used for males and females. So the mortality rate is common for these two people. So if they are a same-sex couple, this assumption wouldn't be relevant. If they're not a same-sex couple, then we need to assume this. Anyways, we use unisex mortalities for this exercise. So we also assume that the lifetimes of the two spouses are independent. So if we call the remaining lifetime, oh, this is funny. We assume the lifetimes are independent. But we also assume that the remaining lifetimes are independent. So we assume that Tx is independent from Ty. And then we're asked to consider an insurance contract where Y receives a unit at time n if at that time X is dead and Y is alive. So they draw a contract at time 0, and at time n, if X is dead, then Y receives 1 unit. So there is one case where Tx is here, right? And Ty is here. In this case, Y receives 1 unit. However, if we have a case where either Ty dies before Tx, and Tx, so if we have a case, for example, where Ty lives past this time and Tx also lives past this time, then there is no payment. And if we have a case where both die before, then there is no payment either. So there is only payment in the case where X dies before time in and Y dies after time in. So what we're asked to do in this exercise is to formalize B of n in terms of Tx and Ty. So goals in this exercise. A, write B of n. And what they mean by this is write it as, as we see in the book, kind of like an indicator of what Tx and Ty have to satisfy for that indicator to be 1. And B is to find the expected present value of Bn. So find the mean of the present value of Bn. And B of n is paid out at time n, right? So in any case, we know that assuming a continuous interest rate, then the present value of Bn is e to the minus delta n. So what we're asked to do is to find the expected present value at time 0, which is the mean of e to the delta n multiplied by B of n. Then C, find the equivalence premium. So find what we call pi, the equivalence premium. Premium, where what do we assume? Where we assume that the premium is paid as long as X is alive. So where we assume premium is paid per year as long as X lives. So the funny thing is, in most contracts, we would say premium is paid per year as long as X lives until time n, because it doesn't really make sense to keep paying beyond the time point where the payout should have been. However, in this exercise, the assumption is definitely that the premium should be paid as long as X lives. So even if X lives past time in, then the premium should be paid. So what we can see is something like this. So if X dies at any time, so at the time Tx, premium is paid no longer. However, premium is in fact paid with 1 unit at each time. Not 1 unit, but with premium is paid with the same amount at the beginning of each year as long as X is alive. So premium is paid with the same amount at the beginning of each year as long as X is alive. And when X dies, there is no payment. So what we actually have is premium is paid as a life annuity due. So we should just write that here. So premium is paid as a life annuity due. As a life annuity due, hence the premium has the expected present value. So hence it has the expected present value pi multiplied by the expected present value of a life annuity due for an X-year-old, which is given by this symbol. So you may actually find this in the book. And if this confuses you, it probably means that you have to read chapter 3 again a couple of times and just freshen up on what a life annuity due is. So premium is paid as long as X is alive at the beginning of each year, which means that it is paid exactly in the same way as a life annuity due. And the life annuity due has this expected present value if 1 unit is paid each year. However, with the premium, pi is paid each year, so hence it has the expected present value pi multiplied by the expected present value of a unit size life annuity due. Now, when we say equivalence premium, what does that mean? Well, equivalence states that, so I can just probably go, we can just write it here. So equivalence tells us that equivalence principle tells us that the expected present value of all benefits has to be equal to the expected present value of all contributions, or so-called premiums. So I kind of used the same word for premium and contribution, but anyways, it means the expected present value of everything that comes out has to be the expected present value of everything that goes in. So the expected present value of all that goes in is this thing here. And the expected present value of all that comes out will be what we find in B. So hence we can find the equivalence premium by isolating pi in this equation.